All right. Hi. Thank you for coming. Happy Thursday. Just to remind you that homework 4 is due today for reals. So make sure you're finishing that up. If you've got questions, I think I have some time after class. I think I have some appointments booked, but feel free to come and just ask or send me an email. The plan is to do some work finishing lab 6, and I'll kind of judge how we're doing by then. So probably around 4 o'clock, I'll call it and then decide if everyone's finished with it, then we're good to go. Otherwise, um, we'll judge. If your partner's not here, hopefully they shared the code with you. Wait, no, your partner's here. Well, if your partner's here, then you're good. If your partner is not here, then we'll need to figure something out. So once we break off into groups, I'll try and walk around, make decisions. So we're going to spend 30 minutes working on lab 6 to hopefully finish that up. We'll briefly talk about something that I'm missing from my code, which is something. So you know where in arrays you can get a value by using the square brackets with an index? My implementation is missing that same kind of functionality, at least publicly. So we'll add that. It'll be a simple fix based on the methods that we've got there currently. But just fix that a little bit. And then around 4:15, we'll start with stacks and queues. So we'll do some slides and talk about it conceptually, and then we'll do some implementation and we'll see how far we get. All right, so let's break into your groups for lab 6 and let me know if your partner's not here. Okay, so we want to have a method in here that gets a value. So something that exists here that we kind of already have is, let's see, we've got get node, which we have the index, and it takes that in as a parameter, and then it returns the node at that index. So if we want to get the data there, then it's simply a wrapper method. So something that we've got the work here in get node that does that for us. We just need to call that and then return the actual data. So let me implement this right below get node. Public returns the actual data. So the type is T. And it takes in some index and we call it get. And so I want to get the node first. And here I'm not going to reinvent the wheel at all. I have a method get node that if I give it an index, it gives me the node at that index. So I just call get node and give it the index. Now I've got the node that contains the data that I want. So since the node's got that data, all I need to do is return the node dot get data. And that's it. So it's just a simple method. Most of the functionality is already there. There may be just a few small things that I'm missing. And that's it. That's how we fix what I was missing. Any other comments or questions from the lab or linked list in general? Okay. So that's how we solve that. let's say, I want to do this now. I do kind of. Okay. So as you're working on the project, I didn't prep this too much in advance, so be aware that things can go wrong. So you're working on the project right now, and you're going to start writing code soon. And if you're working in a group, chances are you want to be able to send code back and forth with each other. And maybe you don't want to zip it and email the zip file all the time. Because maybe you change one thing and then you forget to have it changed in the other, and then that's a whole mess. So the other option is to use GitHub. So GitHub is where all the labs are hosted. That's in the cloud. Okay, I know I didn't prep this in Eclipse. I know how to do it better in VS Code. Let me show you how it works from the Git side. Hold on just a second. Okay, so one of the things you can do is you can make a GitHub account. So if you go to like github.com, you can sign up with your St. Mary's email address, and then you can have all of these different repositories. So like I've got all the repositories for the lab. I've got other things. Maybe. Okay, so in GitHub, you can have public and private repositories. Public meaning anyone can access it. Private meaning I don't want anyone to be able to look at this except me and a few other people. And so if you make a repository for your project code, that's what I recommend. Just so that way, none of your sneaky classmates can go and be like, oh, what are they doing? What are they working on? Keep it private until it's time to turn it in, and then you can just send me the link as opposed to doing a zip file. So let's see. So let's say I've got some code over here. Let's say my in-class project, and I want to put that on GitHub. So let's go to Git. Actually, I need like 30 minutes of prep to go through and figure this out and tell you exactly what things to do. So I'm going to do that tomorrow, and then I'm going to explain the rest of this to you on Tuesday. Sounds good? Great. In VS Code, it's so much easier, but in Eclipse, there's all these little buttons, and it's hard. Okay, so with that, let's go back to the original plan of stacks and queues. So if we go to Canvas, is your partner done? I don't know, you'd have to ask. Okay. Down here in the Unit 5 data structures, we have a new PowerPoint, and we have a new lab that we will probably get to on Tuesday. So let's pull up that PowerPoint. Here it is. Voila. Okay, so we've talked about linked lists, which are a fairly basic data structure. And now we're going to talk about stacks and queues. And so these are different kind of data structures that do different things. So we're continuing talking about how do we store data in a way that makes sense. And the reason we're doing this is, like in real life, different structures help us do different things. So like if you're moving, then you probably want a box to carry all your books from one apartment to the other. If you're just going to class, then you probably don't want a box because it's cumbersome, and maybe you only have one or two books, and so they're all moving around. So maybe a backpack is best for going from class to class. And similarly, you don't want to throw all your stemware into a backpack because then it's all going to get broken. You want a much more regimented, secure type of structure to hold those. So depending on the kind of data that we're working with, we need a different structure. So that's why we're talking about this. The two data structures we'll talk about are stacks and queues. So first we'll talk about stacks. We'll talk about them conceptually, both of them, and then we'll implement them a little bit. And so a stack is a data structure that allows only two operations. So only two main ones that we care about. The first operation is that we add it to the stack. The other thing is that we remove it. And so adding to the stack we call push. Removing from the stack we call pop. So one of the things my favorite analogy for a stack is the Pringles can, where in a Pringles can, you open it at the top and you can only take a chip out. And if you wanted to, you could put a chip back in, right? There's no like cutting a hole in the side of it and pulling out a chip that way, because then the chips get all broken and it's not fun, right? So a Pringles can is a stack. Also, I think not this one, but not the milk aisle, but in the grocery store when they have like boxes that are packed into those like spring-loaded things just on the shelves, and you take one out, but you can't like reach behind. You can only put something in. That's a stack, right? So you can only get the thing at the very front. And so this is an example of a first in, last out structure. So if we're putting chips into a Pringle can, the first chip that we put in, we have to take everything else out first to get that first chip back. Or the other way is we could flip our thinking of it, and let's say we put all these chips in. The last chip that we put in is going to be the first one that we take out, right? So first in, last out, or we could flip that to say last in, first out. So the way we kind of visualize a stack is this, where we've got this basically a boxy U shape, and we can push something to the stack, so add it to the stack, and that it goes all the way to the bottom. And then if we push something again, it goes directly on top. And so from there, we can't access 1 unless we remove 2. And so similarly, we can add 3, and then when we go to pop to remove something, we take out 3, and then 2 is at the top. So we have this notion of the top of the stack, and then our only operations to edit it are push and pop. The other operations that we can care about include peek, which basically asks, oh, what's at the top of the stack? Oh, it's 3, but it doesn't change anything. So the only things that change the state of the stack are push and pop. So push, add something, pop, remove something. In terms of what they're used for, you've been using a stack this whole time. So whenever you run your code, it holds what are called activation records. And so let's say we've got some program here with function 1, 2, and 3. If we run 1, then it gets added to the call stack to say, okay, I'm going to do function 1 right now. And if function 1 calls function 2, then when it's time to do function 2, the compiler is like, okay, we're doing function 2 now. So it adds that onto the stack. It pushes it. And then in the process of doing function 2, we call function 3. And so it adds 3 to the stack. And then when we're running it, and then once it's done, once 3 is done, then it pops that function off the stack. So 3 is done, so it gets popped, and then we've just got 2 and 1. And then when 2 is done, that gets popped, and we're left with 1. When 1 is done, that gets popped, and we're left with an empty stack. And so as we go through our program, we're pushing functions onto the stack, popping them when we're done. And then if we end with an empty stack, then everything's good, nothing went wrong. If something does go wrong, that's what you see. That's all the error information that you see, where it prints the stack trace. And so that says, oh, if let's say something went wrong in 3, then it's saying, oh, I came from 3 and this is what went wrong. And who called me? 2 called me. And this is where it went wrong. Who called 2? Oh, 1 called 2. And so you'll see this stack where it starts with whoever called me, where the error is, and it goes down until it's more and more general. So let's see if we can run, maybe, let's try list demo. Let's try to union list 3 and see what happens. Okay, so this is just in the list demo. So I'm calling a method that I know is going to give me an error because I want to see what the call stack is. And so it says there's an exception. There's an exception, specifically the unsupported operation exception. That comes at the highest level of the stack. And where does that come from? It came from ll.union. And so if we go to ll.java line 225, that's where the exception is. And then it asks, okay, well, who called you? Who called union? Well, then that would be line 25 of listdemo.java. So it keeps track of who called you, where are you coming from, what is the error? And so it gives you the most specific to more general of this is where this went wrong. So we've been using this whole time. We've been using stacks this whole time. Another place that you've been using the stack without knowing it is if you ever take a communication networks class, which is basically how does the internet work? Fascinating, highly recommend. There's the way the internet works is it has this stack of things that the data needs to go to in order to go from your computer to the server and back. And so the way that that works is we go down the stack. So it goes from the application level, to like your web browser in Gmail, all the way down to like the physical fiber optic cables that transport all of our data, and then back up the different levels to get to the Gmail servers or the person you're sending the email to. So stacks are really useful, and we've been using them this whole time. Okay, any questions on stack before we go to the next one? Okay. So the other thing is a queue, and a queue is just a line of elements. So if we were British, then it would make more sense because that's the word that they use for this. So for us, we enter the line at the grocery store. They just queue. So that's probably where the name comes from. But the idea is that a queue is just a line of things where you can get in line so that the operation is enqueue. So that's like the person, if this is the teller at the grocery store, then to enqueue, we just get in line. And then to dequeue, then the person at the front of the line is like, oh, the teller is open. Let me go and check out and get my groceries. And so this is a first in, first out type of structure. So whereas the stack is last in, first out, a queue is first in, first out, which means that if nobody's in line and you arrive, whenever the teller is free, you're the first one to go. So that's first comes, first served type thing. The way we sorry, my word failed me. The way we typically draw that is something like this, where we have there's a notion of the front of the line and the back of the line. So like if you go to the airport, then it's clear, like get in line here, that's the back of the line. And then when you go to talk to the TSA agent, that's the front of the line. And so when they're ready, then they'll be like, okay, come forward, leave the line, and they check your ID and whatever. So when you leave the line, that's dequeuing. When you get in line, that's end queuing. And so we've got this notion of the front and the back. You notice that there's it mentions head and tail. That should be familiar from our discussion on linked lists. That's because linked lists are one of the ways that we use to implement a queue. It's one of the easiest ways because then we don't have to worry about like array size and whatever. We can just say, if we have links going both ways, then we just use that data structure, and then adding and removing is really fast. Because we can just say, okay, I want the thing at the front of the list, or I want to add to the back of the list. And if we have a pointer at both those locations, like hardly any additional work is needed. We don't need to go through the list at all. We can just say, you're at the front, get out of here. Or you want to come to the back? We've added you. Great. Okay, so that's a queue. In terms of what queues are used for, in operating systems and in other things, it's really important to be able to schedule something. So to say, you're doing this thing right now, but I want you to do this thing after that. And so we use queues in order to accomplish that. And there's also, like, if you're typing on a document and then you're like, no, I want to do the other things. There's a queue to be able to do that. Or wait, I think I made this mistake last semester. Is undo, let's just take undo. Is that a queue or a stack? So let's say I type A, B, and C, and then I want to undo. So if I want to undo this, and if it was a stack, then it's last in, first out. And so first I would undo C, then I would undo B, then I would undo A. So this is actually a stack. And I think back is as well, right? But the better example is the milk at the grocery store. So if we've got the person who works at the grocery store and I don't know, maybe draw an apron. They're working here. And we've got our basket. And we go to the milk section and we're like, okay, let me take this and put it in my basket. The person who works at the grocery store can add new gallons of milk behind that. And so that's a queue, right? So the first gallon of milk that the worker puts in is going to be the first one that we, as the customer, take out. And then you've got your classic, like, lines at the grocery store or lines at, I don't know, lines at Oliver to go and get food and swipe your card. That's a queue. Another queue is if you, I really like this example. So have have any of you worked with like really old printers before? Where if you go and like spam print 30 times, the printer is eventually going to print the document that you told it to 30 times in the order that you gave it. Because the first one that you sent is the first one that gets printed. So that's a queue. Oh, I have this one. So like another example of a queue is like if you're waiting in line for pre-orders for the Switch 2, then the first one who gets there is the first one who gets it. Okay, so now that we kind of understand stacks and queues conceptually, we know what they're supposed to do. Stacks have push and pop, and queues have enqueue and dequeue. We want to know how we can implement these. So we know what the high level operations should be. We know what the methods are going to be. And we need to be able to implement each one of these in code somehow to actually store the data and perform these operations. This is actually a good use for interfaces because especially, so we'll start with stacks where I'll do an example where we implement a stack with a linked list and you'll implement it with an array list. And there are different data structures that it relies on, but the functionality should be similar, right? At like our drawn conceptual level, we should get the same result. And so allowing for implementation differences, this is perfect for an interface because an interface is just a method contract where we say, I want the stack to work like this, you want the push operations and the pop operations. That's what they need to be called. And then you can just figure out how it needs to do what it does. So we've got some time. So we're going to create these interfaces. So let's go over to Eclipse. I'm going to go up to my in-class project. I will make a new interface. Let me pull up my code really quick. Okay, so let's put this in. Let's make a package for stacks. And my name is stack. And just like a linked list, the stack is going to hold some kind of data. So we're going to give it the angle brackets. We're going to make it generic to say whatever kind of data you want to put in this stack, I'm okay with that. So we're going to parameterize that. That's what those angle brackets with T does. Okay, so package is stacks. The name is capital S stack with angle brackets and T in the middle, and then finish. Make a new interface. Okay, so in our in-class project, we make a new interface.
What about the package?
I've created a new package called stacks. Okay. So we know what sorry, question.
The invalid Java ball right here.
Is it capital T? And the file is called capital S?
File is called capital S. What's it? Stack capital S.
Yeah. If it looks exactly like this, then you should be okay. Yes, it's an interface. If it looks like this, you should be okay. Come talk to me at the end of class if you're still getting that error. Okay. And so an interface is just a method contract, abstract methods. So we just need a bunch of method signatures to say, we want, is the stack interface public?
Yeah.
Yes. Because we want other people to be able to use this. So we want to push some data. That data is of type T. And I don't know, we'll just give it a variable name. So I've called it X, you could call it data or whatever. So push is adding something to our stack. Similarly, we want to be able to remove something from the stack. And so typically in data structures, you'll see that when we want to remove something, we return the data that was removed. So that's why we have the T here. That's the return type where the goal here is remove that from the data structure. So we take the book out of our backpack, but we don't throw the book away. We give it to whoever asked for the book. So add to the stack, remove from the stack, and return the removed data. So whatever we took out, we need to hand it back. That's the T. And then the other ones that we've got are just these are like the helper methods. So the push and pop, those are our two main operations for a stack. Everything else is kind of just extra that help us do things. And so that includes peek, which looks at the top thing in our stack and returns it. So that's like if if you have a deck of cards and you look at the top card and then put it back down, right? You don't take it off the deck, you just look at it and put it back down. That's peek. And then the others, we want to test if the stack is empty. We want to make the stack empty. Maybe print the stack. And then check if two stacks are equal to each other. Yeah. So those are the other methods. And so I'll give them sensical names. So if the stack is empty, that's going to be called is empty. That's going to give us either true or false. So the return type is going to be Boolean. To make the stack empty, I'll call it make empty. And since it does something and we don't need to get anything back from that, the return type will be void. To print the stack, we just want toString. So that's typical. And then equals is as well, does this stack equal another? And so we'll say that's a Boolean. And it'll take in as a parameter some other thing. So maybe not necessarily a stack, but some other object. And we'll check whether it's a stack and whether all the things are the same as our stack. Okay, that's our interface. Any questions before we move on? Did the error resolve itself?
It won't show up in the, like, I guess, thing, but it lets me like put the brackets and like the actual like code.
Okay, cool. Yeah, and that's how it usually works. Like maybe you get an error to begin with, and then once you start typing, it figures it out. Okay, So that's our interface. Let's make another interface for queues for later. So since a queue is not a stack, I'll put it in a package called queues. And I'll give it a name, QUE, angle bracket, capital T, close angle bracket. Okay, that's my interface. So the main operations with the queue is to add something and remove something. And so in the queue world, I call adding something enqueue, ENQUE, QUE. And we want to add some data to the queue. So we take in some data of type T, whatever we're given. And then we want to, when we want to remove something, it's the same thing, where we want to, in the way we call that for a queue is DQ. That's the method, EEQUE. And the return type, similarly for a stack, whenever we remove something, we want to not only remove it, but return what we took out. So the return type there is T.
This is the QQ. No, like,
You're right. Thank you. Sometimes when I get up here, it's spelling and math that are hard. Thank you. Okay, so those are our basic methods for a queue. And for the others, we just want all of the same ones. So what I'm gonna do is I'm just gonna go and copy those ones. So is empty, make empty, toString and equals. I want all those too. So I will copy and paste. And I'll say. Right, so we want to do the same things. The basic idea is add something, remove something, and we call those two operations something distinct. The reason why it's push and pop and NQ DQ and not like add and remove is because stacks and queues are really, really well-known data structures. And so since they've been around, they've got these names for how they work. So we use those to keep it consistent with the way everybody else uses them. What's your question? You've got what I have. Yep. If you've got all these methods, then you're good. Okay. So we've made our interfaces. Great job. So now we're gonna, what time is it? Let's move my phone where I can see it. Okay, we've got 12 minutes. I think that gives us time. Okay, let's at least talk through how we're gonna do this. So I have to be, so having this idea of like, I want to add things to my stack or remove things from my stack in that way, like I can draw a picture of it, but we have to be able to figure out how are we doing this actually in code? Like, where are we storing the data? How does this look? So we've got decisions to make now. The two ways that we're going to look at creating a stack, one's going to use linked list. So I'll show you that one. The other is going to be using an array list. And so you'll do that one. And so a linked list looks like this, right? What we've looked at so far is linear, which makes sense because our stack also is up and down straight line. So that matches up. What we need to do is we need to figure out how to translate a stack into a linked list. So for a linked list, each node holds some piece of data. So it makes sense that each thing in our stack would probably be in a node, right? So the important thing for a stack is what's on top. What's the next element that I'm going to remove, or what am I adding on top of this? So the main field in a stack is the top. Good news for us, in linked list world, we have a field that can keep track of that really easily. That's the head of the list. And so what we're going to do is we're going to kind of take this stack. So if we've got, let's say 1, 2, 3, and 4, since I've got 4 nodes here, 4 is at the top. What we're going to do is we're going to take this and we're going to kind of rotate it and set it on its side, right? So 4 is at the top of the list. And then 3, 2, 1 are all following it. And so our stack now kind of, if we drew the boxy U thing, it looks like that, like we've just set it on its side. That's what our stack looks like. And so now we just need, now if we define our stack in terms of the linked list structure, all we have to do is say, what does pop look like for a linked list? What does push look like? What do all those other things look like? And for the most part, we have all of those operations. We've got everything that we need to get this done. So that's good. We're just going to choose which methods belong to linked list to get things done for a stack. So to push something onto the stack, that's just like inserting. So if we add 5, we're just going to call insert at the beginning of the list, which is position 0. So whatever data we have. And then to pop something off the stack, we need to just remove the thing at the head of the list and then return that data. So remove the thing at 0. That's what we're going to do. So once we've done all that work for linked lists of defining here's how that works, we just use that. Okay, let me make sure I've got. Okay. So in my stacks package, I'm going to make a new class. And this is, I'm going to call it LL stack to say this is a stack that is implemented using a linked list. So LL stack, and it's still going to hold some type of data. So we need to give it angle brackets and the T as well. And so once we do that, we give it a name and we just need to say it's going to use our stack interface. And make sure that the inherited abstract methods, make sure that box is checked. Okay. So once I click finish, then it's given me the override for all these things, which is great. So now I just need to say, here's what that means. So first I need an actual linked list. I don't currently have that. I know it lives in lab 6, so I didn't test this beforehand, but I think I should be able to right click on that LL class and go and copy it. So if I copy that, and then if I right click on stacks, I should be able to paste it. Yeah. And so then my LL class shows up in there. Oh, now I've got an error that node isn't there either. So linked list depends on nodes, so I need that one too. So I can go and copy that one as well. So go to the file I want, right click. I'm betting you anything this also works in VS Code, where you can copy files. So copy node, go up to my stacks package, right click, and paste. Voila, no more errors. Okay. So now I've got my linked list class in this project that I can go and use. So before it lived in the other project, but now it lives in this project.
Linked lists again.
Yes, for this one. We do. Okay, so to push, we just need to, we've already talked about how this works. We already know how we're storing the stack. We're storing it as a linked list. And so I don't know, what do I call it? In my notes, I call it list. And so then let me make a constructor. And in my constructor, I will say list equals new LL containing whatever type. So we're just going to create the empty list. All right, the other option I have, which I think makes testing easier. The other option I've got is for a constructor that takes in some array. So maybe storing things as in an array is easier for me. And I just want to convert it into a stack by just giving you, here's all the things that I want to be in my stack. So I'll take in an array of type T. So I'll make the empty list, and then I will say for each element in that array, I will say maybe this dot push that data. So I haven't defined what push means yet, but I want to insert that information into my array, into my stack. Okay, so we're almost out of time. So next time we will resume with push pop peek is empty, make empty. These guys are easy. These guys are also easy. It'll take us 3 minutes. because all the work's done for us in our linked list already. So for active learning today, if you would submit, choose one, so either stack.java or q.java, choose your favorite and submit that. So today's the 24th. So do that, and then I think I'll keep lab 6 as due today, so take a few minutes after class to figure it out if you're not completely done with it. And then we're good to go. Make sure you submit the script on tomorrow. The script is due tomorrow. So make sure you talk with your group and you've got something written up for that. Once you do that, you're good to go. Thank you, and I'll see you on Tuesday.